Hey guys, so here we are for the cosine wave. So normally when I teach sine and cosine, we have a sine wave day 1 where we go through the lesson of the sine wave, that whole thing, and then we spend a second day practicing some more graphing. And then I do the same thing with cosine. So obviously because of the distance learning thing that we're doing right now, I didn't see a point in doing that because you're able to do it online anyway. So I will be trying to find a way that you could practice it digitally, or at least being able to identify these things that you're learning so that you don't have to do it by hand all the time. But doing it by hand, it puts us through those motions where we know what to expect and we know what we need to find, and that's important. Those are key components. So bear with me on those. Yeah, they take a little bit longer. They take up a lot of paper, but I don't know, they just look really cool. Okay, so you just gotta have a good attitude about it. As with anything in life, it's all how we take it on, our attitude. So today is the cosine wave, and we are going to be looking at the parent function of cosine is y equals cosine x, just like the parent function for sine was y equals sine x. And the cosine wave starts a little bit differently. It starts up and then goes down, up, down, up, down, up, down, up. So our cosine wave is going to look more like that. Okay, so we still are going to be dealing with our t-chart. We still are going to be dealing with the unit circle. But remember how the sine wave, we were looking at the y values? That's because we were dealing with sine. And in a graph, cosine is the x value and sine is the y value. Well, today we're dealing with cosine. So we're going to be looking at the x value of all those points on our unit circle. So remember, we start at 0 and then going counterclockwise around, pi over 2, pi, 3 pi over 2, full circle back to 2 pi. And then our coordinates were the points, oops, it was already clicked. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. Our t-chart is going to involve the same values that we had on the last set of notes. So we're going to have, starting counterclockwise, 0, pi over 2, pi, 3 pi over 2, 2 pi. And then going in the clockwise direction, we would be at negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Remember, counterclockwise is positive degrees and radians, and clockwise is negative degrees and radians. Okay, so let's plug in these x values. So if we have the cosine of 0, well, the cosine of 0 is 1. The cosine of pi over 2 is the x value is 0. The cosine of pi, the x value, negative 1. Cosine of 3 pi over 2, 0. Cosine of 2 pi, 1. And then negative pi over 2, back down here. So cosine of negative pi over 2 is 0. Cosine of negative pi, negative 1. Cosine of negative 3 pi over 2 is 0. And cosine of negative 2 pi, 1. So again, zeros, ones, positive ones, negative ones, all of those. Okay. All right, so we are ready to graph. So let's go ahead and put these marks on our graph. So for the y-axis, let's have 1 unit above and 1 unit below. And then we're going to have a pi over 2, pi, 3 pi over 2, 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay. And our midline, because it's the parent function, we weren't shifted up or down, is, I'm going to use a different color this time, I'm going to use pink, is still the x-axis. And I still am going to use a highlighter to mark that. If you don't have a highlighter, just use a colored pen, pencil, crayon, whatever's around, but something with a different color. Okay, and let's go ahead and graph the fun part. What color do I want to use? I think I want to use that teal. I like this one. Okay, so we're going to start at 0, 1. So that's up here. And then pi over 2, 0. And then pi negative 1. And then 3 pi over 2, 0. And then 2 pi 1. So 2 pi. Okay. Now for the negative side, I'm going to have negative pi over 2, 0. Negative pi, negative 1. Negative 3 pi over 2, 0. So back to the midline. And then negative 2 pi, 1. Okay. So we always start above the midline and we go down, down, up, up. Down, down, up, up. Down, down, up, up, down, down, up, up. For sine, we went up, down, down, up. Okay. All right, so there's our cosine wave. And our normal start is also at 0. Okay. Well, the x is 0, but the y value is 1. Our normal stop is always at 2 pi. So our start and stop are still the same places as sine, 0 and 2 pi. Okay. So, yeah. Okay, and I like to point out that we start up above the midline, and then we're on the midline, and then we're down below the midline, and then we're back on the midline, and then we're up. Up, on, down, on, up. Okay. All right, so next, let's take a look at standard form of cosine. Okay, so cosine standard form is almost exactly the same as sine, except for it says cosine. That's the only difference, really. Okay, so let's take a look-see at what we've got going on here. So first of all, we have amplitude, which is the distance the graph goes above and below the axis, just like the sine wave. Remember, distance is always positive, so that's why it's under absolute value. So if it's negative, that just means it was reflected. Remember that from sine. But when we're looking at amplitude, we just need the positive version of it, because remember, that's how much above and below the midline we have to go. The period is 2 pi over b. Okay, still, period's still the same way. It is how long it takes to complete one cycle. Okay, and then the phase shift is our movement to the left and to the right. So it's C, it's left or right. Okay, and our vertical shift is how much up or down. The vertical shift also moves our midline. So let's also add that to our note. It moves the midline. So the vertical shift is really what's super important. Well, it's all important, but vertical shift is super important. Okay, so now for our start and stop. Remember, our start is going to go the same way that the sine wave did. You take the b times x minus c, this, and you set it equal to 0. This is our normal start, just like for the sine. And what you do is you solve for x, and you get x equals something. And that is where we start at. The stop is the same thing as sine also. You take the b times x minus c, and you set it equal to 2 pi, because that is our normal stop for a cycle. And you solve, oops, gotta spell it right, solve for x, and you're gonna get x equals something. And once you have these, it makes the graphing easy. You don't have to write this, but you know me and my little quirky things that I do. Makes graphing easy. Okay. All right, let's get down to it. So pretty much it's the same thing as sine. All the steps are the same. You still have to find your list of 5 things. The only thing missing here are the increments, but we find them the same way that we did sine. And once we find those increments and we know our start and stop, we just use the pattern of the cosine. So instead of starting on the midline, we start that amplitude above the midline and then go down, down, up, up. That's the only difference that we have to do. All right, so hopefully you guys have some graph paper. I have it ready to go. So our first example is number 1, y equals the cosine of x plus pi over 2. So let's start by making our list. So for our list, we need the amplitude, we need the period, we need the increments, phase shift, vertical shift. Okay. All right, and let's go ahead and identify those things. Well, in this case, there's no number in front of cosine, so that means that the amplitude is a 1. The period is where you take 2 pi and you divide it by b. The b value is also a 1. So 2 pi over 1 is just 2 pi. So there's our period. The increments we take by taking we get the increments by taking 2 pi, the period, and dividing by 4. And when we reduce that, we get pi over 2. Okay. The phase shift, because it says plus pi over 2 there in parentheses, that means that it changed from standard form. So that means that this value that plugged in must have been a negative, because only a negative times a negative can make that sign turn to a positive. So we went to the left pi over 2 in the negative direction. And there is no plus or minus a number after the parentheses, so there is no vertical shift, which means the midline is still the x-axis, which is nice because that saves us some time. We don't have to worry about a vertical shift. All right, the next thing is our start and stop. So our start, we take the b times x minus c, which is x plus pi over 2. And we set it equal to our normal start, which is 0. For our stop, we take the same thing, x plus pi over 2, and we set it equal to 2 pi, and we solve for x. So for the start, I would have to subtract pi over 2 on both sides, and 0 minus pi over 2 is a negative pi over 2. So we're starting on the negative side this time, but that's because we went to the left. So we're going to start at negative pi over 2. I need to subtract pi over 2 from both sides for the stop. I'm going to write it over here. Okay, and I have my pencil ready because I'm going to have to get a common denominator. I'm going to have to multiply this one top and bottom by 2. So I would get 4 pi over 2 minus 1 pi over 2 is 3 pi over 2. So there's my stop. So I'm starting at negative pi over 2. I'm stopping at 3 pi over 2. And my increments are pi over 2s. That's nice because I will already have a common denominator. Kids, you either need to settle down and be quiet or get out of here. Lucas, you need to get out right now. You're being rude. I'm really sorry, guys. Lucas, get out. All right. Sorry, guys. I'm really sorry about that. Okay. So I'm going to put the increments down here. So I have negative pi over 2. All right, both of you get out now. Violet, Lucas, out. I said get out now. All of my students are hearing me yelling at you guys, and you both are being incredibly rude. Okay. So we are adding the increments, which were pi over 2. So I'm adding pi over 2. Oh, and I forgot to circle that because I got distracted. All right, negative pi over 2 plus pi over 2 is 0. So that's my next mark. And I have to add pi over 2. 0 plus pi over 2 is just pi over 2. Isn't this easy? It's not so bad. Increment, pi over 2, so add another pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which the 2's would cancel, and that would reduce to a pi. So I have 1, 2, 3, 4 marks. I need my last mark, plus I haven't gotten to 3 pi over 2 yet. I'm going to use the unreduced version, the 2 pi over 2, and add another increment of pi over 2, and that's going to get me there. 2 pi over 2 plus pi over 2 is 3 pi over 2. And those are my marks, my 5 marks. Okay, so now I am ready to go to the graph. So I have my graph paper here, and this is example 1. And let's remember what we need. Our amplitude is only 1. We were shifting to the left, so I need some on the negative x side. Okay, so sorry guys, the kids are just out of control right now. I'm still recording, Nicholas. Okay, so there's 1 mark, 2, 3, 4, 5.
Come out there when you're done about it. Sorry.
Okay, all right, so my marks were a negative pi over 2, 0, which is the origin, and then pi over 2, pi, and 3 pi over 2. So I have a little extra one there. That's okay. All right, my amplitude was only a 1, so I only need 1 above and 1 below. Okay, there was no vertical shift, so that means that my midline is still at the x-axis. Again, guys, I'm sorry I had to yell at my kids in front of you. They're being a pain. No matter how many times I coach them, no talking while I'm videoing, it doesn't matter. They still do it. They still get into trouble. Anyways, okay, so we are starting, our start is at negative pi over 2. So remember, cosine doesn't start on the midline. It starts the amplitude above the midline, and the amplitude is 1, so I have to start 1 unit above the midline, okay? And then I go to the next point and I go down. And then at my next mark, remember, it goes down, down, so down again, and then back up to the midline, and then 1 unit above. So it goes down, down, up, up. And if I were to continue going, it would go down, down, up, up, or down, down, up, up, depending on which side you're looking at. Okay, so there's my fancy U right there. There's my cosine wave. That was number 1. Okay, this lesson only has 2 examples, so we have 1 more left to go, which isn't bad. All right, so what color do I want to use now? I think I want to use red. Let's use red. Okay, so number 2, y equals 2 cosine of 1/3 x minus pi over 6 minus 1. Okay, there's a 1/3 in front of that x, so we need to factor that out. Okay, so we need to rewrite this because my phase shift is hidden in there. Okay, so this will be y equals 2 cosine. We're going to factor out that 1/3. And then in the parentheses, 1/3 x divided by 1/3. Anytime you take a number divided by itself, even if it's a fraction, it turns into 1. 1/3 divided by 1/3 is 1. And then I have a negative, so a negative divided by positive is still negative, okay? So now I have negative pi over 6 divided by 1/3. So I have pi over 6 divided by 1/3, but dividing fractions is easy as pi, flip the second and multiply. Since I'm dividing by 1/3, I now have to switch to multiplication, and the reciprocal of 1/3 is 3 over 1. 3 goes into itself once, goes into 6 twice, so my final answer is pi over 2. So minus pi over 2, okay? So that skill from the warm-up from the sine lesson is still important. You're still gonna need it, and you're gonna be using it a few times, okay? So now we have this ready to go, and we can make our list. So I'm gonna start with the amplitude. So we need amplitude, period. We need our increments. We need the phase shift, the vertical shift, and those are my 5 things. Okay. The amplitude in this case, the A value is a 2. The period would be 2 pi over B, but B is a fraction, it's a 1/3. So it's 2 pi divided by 1/3. Okay, so 2 pi, but instead of the divide symbol or even the divide symbol, remember dividing fractions easy as pi, flip the second and multiply. So the reciprocal of 1/3 is 3/1, which when we multiply across, that is just 6 pi. So our period is 6 pi this time. And our increments, so you take the period and you divide by 4. 6 pi over 4, that reduces to 3 pi over 2. So those are my increments, okay? And the phase shift, if we look at our fixed version, it's minus pi over 2, so that means we're going to the right, pi over 2. So we're not going to start on the negative this time. And we do have a vertical shift. That -1 means that we are going down 1. So the midline has moved. We have to make sure that we shift it down a whole line, okay, a whole unit. All right, so we have all that. We have our list, and now we need our start and stop. So the start is where we take the b times x minus c, which is the 1/3 times x minus pi over 2, and we set it equal to 0. And then for the stop, we take the same thing, the 1/3 x minus pi over 2, and we set it equal to 2 pi. Okay, and then we have to solve for x on each of these. So don't distribute the fraction. It's way, way, way easier to just get rid of it by multiplying by its reciprocal, 3/1 or 3, to both sides. So we get rid of it on the left, and we basically got rid of it on the right, because 0 times anything is still 0. So I have x minus pi over 2 equals 0. Add pi over 2 to both sides, you get x equals pi over 2. So this is where this function is starting at, pi over 2. For the stop, we're going to do the same thing. I'm going to switch colors, though, because I want to separate that. Okay, so let's use the darker blue. So I'm going to multiply by the reciprocal again, which is just 3, because that will cancel, and I will get x minus pi over 2 equals 2 pi times 3 is 6 pi. And I need to add pi over 2 to both sides. I'm going to write it over here. Put the 6/1. And I'm going to need to get a common denominator. So I'll have to multiply top and bottom by 2. You guys are going to get so good at getting common denominators. And okay. So 6 pi over 1 times 2 top and bottom would be 12 pi over 2 plus 1 pi over 2 is 13 pi over 2. Yeah, it's okay to get weird fraction numbers. It's okay. The only time you think anything of it is when you're finding the increments and you get more than 5 increments or you get less than 5 increments. That's when you need to be concerned. All right, so we have our start and we have our stop. So let's figure out those increments. So I have my pencil, and we start with pi over 2, and I'm going to circle it, and I remembered to circle it this time because I didn't have any distractions. And our increments are by 3 pi over 2s. So I got to add 3 pi over 2. Okay, pi over 2 plus 3 pi over 2 is 4 pi over 2. And that reduces to 2 pi. I'll write it underneath. I want to keep that version there because I have to add another 3 pi over 2, and that way I still have a common denominator. 4 pi over 2 plus 3 pi over 2 is 7 pi over 2. Can't reduce that, so there's my third mark. I have to add another increment, so 3 pi over 2. 7 pi over 2 plus 3 pi over 2 is 10 pi over 2, which reduces to 5 pi. And I'm gonna, I could squeeze it in here. Add another 3 pi over 2. And I'm gonna get 10 pi plus 3 pi is 13 pi over 2, and that is my stop. So I got my 5th mark, okay? It will always be 5, always, always, always. All right, I am ready to graph. So let's go ahead and get to the graph paper. Grab my black pen. This is number 2. Now this time the amplitude is 2. I was shifted down 1, so I am gonna need a little bit more on the negative side. So let's do that. So let's draw the x-axis up here. Okay, and let's see, the amplitude was a 2, so we'll have 1, 2, -1, -2, -3, okay, and pi over 2, the next mark was 2 pi, then 7 pi over 2, 5 pi, and 13 pi over 2. So my 5 marks, okay. The midline, remember it was, what did it say? On our list, it was shifted down 1. So that means that instead of being on the x-axis, I have to go down a unit, which is at y equals -1. Okay, so I'm over here. So this is my midline now. Okay, all right. I'll use this blue pen. Okay, so our start is at pi over 2, and we always reference the midline, and the amplitude on our list is a 2. So I have to start 2 above the midline. So 1 unit, 2 units, so I'm up here, okay? And then at the next mark, I am back down to the midline. And then at the next mark, I'm gonna be 2 units below the midline. So 1, 2. And then at the next mark, I'm back to the midline. And at the next mark, I'm gonna be 2 units above the midline. 1, 2. So it goes down, down, up, up. And I always curve it on these endpoints because this wave will continue to go in both directions, okay? And there is the cosine wave. All right, so that's all there is to it, guys. It's the same process as sine, except cosine starts at a different spot. And you have 8 problems to do here. So it's all gonna be the same type of thing. You gotta make your list. These two, 7 and 8, you're gonna need to factor out that 3, and here you'll have to factor out that 1/2 before you make your list. And because your phase shift is hidden in there, you gotta see what it is. All right, guys, so that is all. Have a good one. This was a much shorter lesson. It is half the length of the sine wave, so we were able to lay the groundwork with that one. So I hope you guys are doing all right. If you have questions or if you need me to go over any examples again or homework problems like in a Zoom in person again, I have no problems doing that. So do not be afraid to ask me. You will never bug me. So keep sending me those emails, keep commenting on my videos, those of you that have been. I appreciate that, and I miss you guys so much, and it sucks having to teach you this way, but it's all we got right now. So at least it's something, and at least I can still teach you this way. And have a good one. I'll see you in my next video.